Welcome to Brain Vision.
Let's do this chemistry problem about acid and bases. But before I get started, I recommend that you pause the video, do the question yourselves, and come back to see if you got it right or not. So we want to find the pH, right? pH of hydrogen fluoride solution at different concentrations. So we're given 3 different concentrations and we want to find the pH, right? So it asks, in which cases can you not make the assumption that X is small? Well, for that we would need the Ka for HF, and the Ka, you can find it online anywhere, 6.8 times 10 to the power minus 4. So for all of the cases we can't make the assumption that X is small. Usually when we can make the assumption that X is small, it's when the Ka is like times 10 to the power minus 5, right? Or more. And this is because if you do 1 minus right, it would be 0. So this value would end up rounding to 1 anyway, so it doesn't really have an impact, so we cannot assume that K is small, right? Now that we've hopefully understood why we cannot make the assumption that X is too small, let's get started with the problem. So we are given 0.25 hydrogen fluoride molarity, and we want to find the pH. So it would be very helpful to draw an ice table since this is a weak acid. So we do we're not given a concentration of H plus and F minus, so we're just gonna assume that it's 0. And then we can easily write the Ka formula. And obviously we can substitute Ka, we can substitute 6.8 times 10 to the power minus 4, make it equal that. Let's multiply it. And then multiply the brackets. And we can solve for X. If you're allowed to use your calculator, you can use the equation function using a non-programmable calculator. But if you're not, then you can just use the formula that you all know about. Where A is going to be 1, B is going to be 6.8 times 10 to the power minus 4, and C is going to be 1.7 times 10 to the power minus 4, right? And that should give you X to be about 0.0127. But if you notice, we're not done yet because we have only calculated x, which is just the concentration of H plus, right? The hydronium ion. So what we would actually need to do is minus log this concentration to get that pH. So we do pH minus log, and using your calculator you should get 1.90. It's 1.896, but we would round it up, and pH is to 2 decimal places, so you would have to put 90. And honestly, you can do the same procedure for the next two concentrations, right? 0.05, so that. You can do the same thing, so you can do the ice table. Let's just skip a few steps, make it a bit easier because we already know the procedure. Do the ice table, and you should get, it looks like already, but it's actually Ka. You would get x squared over, and you can't make the assumption that x is small, so we would have to do a quadratic formula using the same Ka, of course, because it's the same weak acid. And you can solve for x. Puts you 0, of course. And then you should get x, which is, using a calculator, about 0.055. And this is just the concentration of H plus, so we can calculate pH by doing minus log of that. And that should be about 2.28, right? So you can do the same procedure for the next step, and hopefully that was helpful.